Have you ever wondered how we react so quickly to sounds around us? Every day, our brains perform the remarkable task of translating sounds into actionable responses. Imagine hearing your phone ring. Almost instantaneously, you reach out to answer it. Or consider the sound of footsteps in the dark, prompting a swift turn of the head to identify the source. This innate ability to convert auditory stimuli into physical actions is not just a trivial aspect of our daily lives. It's a sophisticated survival mechanism. The process involves more than just hearing a sound. It requires the brain to interpret what the sound means, decide on an appropriate response, and then coordinate the motor actions to execute that response. This seamless integration of sensory input with motor output allows us to communicate effectively, navigate our environments, and interact with the world around us. Understanding this process is not just fascinating, it's crucial for decoding the mysteries of human behavior. But how does the brain manage such a complex task? At the heart of our understanding is the brain's cortex, an area divided into two main types of regions: sensory and motor. The sensory areas are like grand stations of information, where sounds from our environment are processed and interpreted. Here, neurons buzz with activity as they decode the myriad sounds that reach our ears. But the plot thickens. Recent discoveries have unveiled that these sensory areas, traditionally thought to be dedicated solely to processing sounds, also contain signals related to movement. This finding was quite unexpected, as it blurs the lines between sensory processing and motor execution. It suggests that the areas of the brain responsible for hearing might also play a role in planning or initiating physical actions. This overlap of sensory and motor functions in the brain raises intriguing questions about their interaction. How do these regions work together to translate a sound into a response? And what does this mean for our understanding of brain functionality? This complex interplay hints at a more integrated and dynamic brain than previously imagined. Researchers at the Champalimaud Foundation crafted a unique experiment to delve deeper. In their laboratory, they set up a task where mice were trained to discriminate between high and low tones. The decision-making process was simple yet ingenious. If the tone was high, the mice would lick to the right. If it was low, they would lick to the left. This design not only tested their auditory discrimination, but also their ability to link these sounds to specific actions. A critical component of this experiment was the half-second delay inserted between the presentation of the sound and the opportunity for the mouse to make its choice. This brief pause was pivotal. It allowed the researchers to cleanly separate the brain activity triggered by the sound itself from the activity associated with the decision-making process. Furthermore, the experiment was cleverly designed to include the possibility of errors. This was not a flaw, but a feature. By analyzing the wrong choices, scientists could further distinguish between the brain's encoding of the stimulus and its encoding of the choice. This setup allowed scientists to pinpoint how the brain processes sounds and plans actions simultaneously. What did the recordings reveal? As researchers delved into the auditory cortex, they embarked on a meticulous journey through its multiple layers, each uniquely structured to process sounds and guide actions. The auditory cortex isn't just a simple receiver of sound, but a complex, multi-layered network where various types of neural activity interact dynamically. The study focused on capturing the fleeting dance of neurons across these layers as they responded to auditory tasks. What emerged was a clear pattern. Sensory signals sparked quickly upon the detection of sounds, illustrating the brain's rapid response to auditory stimuli. However, these signals were not long-lived. They diminished as swiftly as they appeared, making way for something more sustained and profound. Intriguingly, as the initial burst of sensory information receded, choice-related signals began to surface, primarily in the deeper layers of the cortex. These signals, emerging later, hinted at a deeper level of processing, where the brain was possibly weighing decisions or preparing for actions. These distinct patterns suggest a sophisticated orchestration of brain activity across layers. But where do these choice signals come from? This question leads us to the higher echelons of the brain, where planning and execution of movements are orchestrated. Fascinatingly, the origins of these choice signals are likely nestled in these elevated regions, suggesting a top-down influence on auditory processing. Delving deeper, researchers hypothesize that these choice signals are not merely byproducts of brain activity, but play a pivotal role in integrating sensory information with the decision-making processes. It appears that when a sound is heard, it's not just processed as an isolated event, rather, it's evaluated in the context of potential actions. This integration ensures that every auditory cue is sifted through a filter of relevance and potential response. Moreover, these signals likely serve as a bridge, connecting the dots between what is heard and what needs to be done. By doing so, they ensure that our responses are not just reflexive, but are deliberate actions aligned with our intentions. The role of these signals might be crucial in aligning our perceptions with our actions. What's next in unlocking the secrets of the auditory cortex? The road ahead is paved with intriguing questions and boundless possibilities. As researchers delve deeper, the focus sharpens on the precise origins and roles of movement signals within the cortex. Understanding where these signals originate and their exact function could revolutionize our grasp of neural mechanisms. The broader implications of this research stretch far beyond the laboratory. By unraveling how the brain transforms sensory inputs into motor outputs, we edge closer to comprehending how sensory-motor transformations contribute to our conscious experience. This isn't just about understanding how we react to sounds, it's about piecing together how we experience and interact with the world around us. Future studies will likely explore the causal relationships between sensory inputs and motor actions, further detailing how our brains construct reality from the myriad of stimuli we encounter every moment. The path forward is as exciting as it is essential for unraveling more about our brain's capabilities. So, what have we learned from this groundbreaking research? The Champalimaud Foundation's study has illuminated the complex ballet that occurs within our brains, translating the mere sounds we hear into decisive actions. This research has meticulously detailed how sensory information from the auditory cortex not only triggers immediate responses, but also influences subsequent decisions, painting a dynamic picture of brain function. Central to these findings is the interplay between sensory and motor signals within the brain's cortex. Sensory signals are rapid and transient, quickly alerting us to changes in our environment, whereas motor signals, which guide our actions, emerge more gradually and are sustained longer. This delicate balance ensures that our responses are not just reflexive, but are also appropriately tailored to the context of the sound. Moreover, this study underscores the importance of the auditory cortex, not just in hearing, but in the integration of perception and action. This dual role is crucial for tasks ranging from the simple to the complex, influencing everything from basic survival instincts to sophisticated decision-making processes. As we continue to explore, each discovery brings us closer to understanding the incredible orchestra within our heads.